So how we just the defined distance, just recalling what you learned last day. It is the length of the path or length of the trajectory, right, taken by an object. So at the same time, we described the just distance between 2 points is not meaningful, right? Now, when you say the distance between 2 points, it is not meaningful. Why? Because it depends on the path taken. Between these 2 points. Now, let's say, for example, from Paliyagoda to Vattala, in case somebody is going to ask, hey, what is the distance between Paliyagoda and Vattala, or distance between Vattala and Paliyagoda? So you have to ask a question immediately. In turn, from the person who raised the question. Right? Now you're asking distance regarding what path? There are so many paths between the Paliyagoda and Vattala. So you are referring to the distance regarding what particular path between the Paliyagoda and Vattala. So one of the important facts we emphasized and we absorbed was that distance is not something just just between 2 points. It is always specific when it comes to the path. So therefore, if you say distance from Paliyagoda to Vattala along this particular path is, let's say, 4 kilometers, or let's say the 5 kilometers, right? So that is the way. The path is, particular path taken between these 2 points is very, very important when it comes to the distance, because distance depends on the path taken. It is one of the important properties. Okay, right. At the same time, it was a scalar quantity and just measured by, the meters, or you can measure by any unit of length, like kilometers, right? Depending on the size, the millimeters, and so forth. Right, fine, good. Now, one of the very important points. Very important points regarding distance, right? Is something like this. Now, if I ask, can you talk about them? Can you just can you respond me in case I'm going to ask questions? What is it? You can talk right now. Permissions have been granted, so you can talk to me, right? You can just type. Most probably, the next Thursday, we are going to have the physical classes, right? The on-site classes, maybe. From most probably 3 or 3:30 onwards. And today, that was because of a special reason, right? I got my final reports. As I was maybe sick the last few days, and I got the final reports, and it was mentioned. I was weekly positive for CO19, right? So I thought of rather than the making some kind of taking some risk, right? Especially when it comes to your health, it's better to have the class. Otherwise, I actually I wanted to have the on-site classes with you today. But once I got the reports in the morning, I decided rather than taking a risk, it's better to have the today class also online, and then let the things to disappear completely, so that we can have the on-site classes next day onwards. But definitely before next Thursday, right? The few more classes will be conducted, right? Will be held. So those classes are going to be online. Just to make sure that let's say just to cover up maybe 1 or 2 classes, right? We couldn't conduct it as because I was a little bit down, right? Now it's okay. I think 99% Yeah, something is okay. Fine. Now, if I ask one small question from you regarding the what's called this, distance, right? Let's say, in case I'm going to ask, what do you think about the distance? Can somebody move in a way that distance decreases? What do you think, Mamata? I mean, you can answer, right? No problem. Now, the question is, in case I'm going to ask from you, can somebody move in a way that distance decreases? Now, for example, let's say, now you have gone through these distance time graphs, speed time graphs, probably velocity time graphs, right? And so forth. Probably not. It doesn't matter, right? I'm not going to assume you have done something regarding motion graphs, distance time, displacement time, speed time, velocity time, acceleration time, force time. These graphs, whether you have done or in case you have some knowledge, is okay. But in case you don't know anything about that, right? That's also completely fine. But because we are going to do from the scratch, from the ground level up. Don't worry about that, right? I mean, let me make it to the topmost. Fine. Now, let's say like this. So if I take the distance, dist for short, right? And if I take time to the x-axis and distance to the y-axis, right? And I'm going to draw a graph like this. Let's say it's a straight line, and it's going to be something like this: O, A, and that point is going to be B. Topmost point A. So there are actually two portions in the graph. O to A, we have first line segment, and A to B, we have the second line segment. So, I mean, once you add these two line segments together, OA and AB, you will get the entire the graph. So this is how, in case, let's say, in case somebody has drawn this graph for you, right? I mean, regarding an object which is moving along a straight line. So that person is going to tell you, this is how distance of this particular object is varying against time. Distance against time, right? Now I'm asking just one small question. What do you feel about this graph? In case somebody is going to ask, okay, can you just tell me? I mean, or can you just criticize? Can you just tell me what do you understand when you look into this graph? What do you feel when you look into this graph? The variation of distance against the time. What do you think? Come on. Mamata, you can talk. You can talk, right? You can talk, you can type, you can whatever. It's completely fine. So, yes. Come on. What do you think? I mean, what do you think about this particular graph? Distance time. OA, AB. What comes into your mind when you look into this distance time graph? Come on. What do you say? Any idea? I mean, like, answers can be correct, answers can be wrong. It doesn't matter, right? Always I'm asking you to give it a try, Manpuda. I mean, actually trying, attempting is the most important thing.
How can distance go down?
Manpuda?
How can the A to B line segment have a negative gradient?
Okay. Right. Now, little bit heavy, right? I mean, that question is really, even though Manpuda asked a question, that question is quite impressive. Right, I'm really heavy. Okay, anyway, now, all right, rather than asking a question from me, if I ask, if I ask you to do something like this, Mamata, can you explain that graph? What do you understand? What do you feel about that graph? So you can say that graph cannot be accepted, that graph, probably that graph object is going with a uniform velocity. Now, Professor Shen is telling constant increasing velocity and constant decreasing velocity. Oh, that's how he feels about it. So, now, okay, before I'm going to explain, I want you to give it a try. What do you think about this graph? How do you feel about this graph? In case you have a problem with the graph, you can tell that thing also. So I don't think it is blah 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 and so forth. Like, come on, you can tell me all these things. But the thing is, before I'm going to take the graph, into my hands, right? I want you to go give it a try. What do you think? Rehan, okay, fine. One of the giants. Okay, the graph cannot be accepted. Well, oh, right. So it's really nice. And then Mahmoud Rehan, come on, mate. My gratitude and highly appreciated. And I'll tell you one thing. For the time being, probably one of the giants in school, right? That's for sure. I mean, like, because I'm with the experience usually we are having in the field. So when a question like this is being raised, and depending on the answers, usually we get right from you. So usually we can decide within a fraction of a second somebody who is going to go to that level, somebody who is going to go to that level, and somebody who is not having a level at all. I mean, sky's the limit, something like that. So definitely should be somebody. I mean, even though yet I haven't gone through right completely. Definitely, I can tell you one thing, right? I mean, one of the best. You should be one of the best. I mean, like smart guys. The performing in the school for the time being, right? Just really good. Hold on, my dear, and then keep going. I wish you all the best, and I'm there always. Inside your come on, yeah, inside your career. Okay, so will help you. To get your dreams. Yeah, true. Okay, really good. It should be a curve graph, right? Yeah, sometimes it can be a curve. But now, the most important thing here is this. Now, let's say distance is the length of the path taken, right? Distance is the length of the path taken. So now let's say, if you take this object, now one object is there, let's say starting from point O, and it keeps moving all the way up to somewhere down here, right? Up to there. Now the distance which has been covered by this object for the time being, just till this moment, is going to be the length of the path taken by the object. So the path taken by the object is shown here. So Maguda, what you have to do, just get that path. Okay, we talked about that thing, right? So just you can, let's say, literally, virtually, you can lay down a piece of, let's say, string along the path, aligning with the path, right? And you can take that piece of thread and hold it against a ruler, and you can get the, oh, okay, wow, it is that long. So easily you can get the length, right? So now likewise, now distance which has been covered for the time being, let's say for example, S1 up to there. And let's say now this particular object which is there right now is going to take few more steps, right? It's going to take few more steps. Let's say probably along this way, right? Okay. Probably then after that up to somewhere here, it is going to, let's say, follow a straight line path. Now, in case we want to find out total distance which has been covered from point O, then what might we have to do? Keep adding all these, come on, lengths of the paths. So first part S1 and second portion, let's say S2, that one, right? And let's say this portion is going to be S3. So now total distance covered is going to be what? S1 plus S2 plus S3. So ultimately the come on, entire path, right? From the beginning to that point, the total path taken and the length of the entire path is going to be the distance covered. Then now, okay, in case this person, probably, let's say you, your home, your school. Now, in the morning, you came all the way along that path, and now you're in the school, and somewhere around, let's say 1:40, 1:45. Now, school is over, and you are about to go back. Now what? You keep going along the same path. We'll reach there, and then again, we'll take that path, and we'll go, and we'll be at home, right? We'll go home. So, in that case, what's going to happen? Right? I mean, the length of the path taken. So now you're in the school right now, right? And then after that, what's going to happen? You will start going back. So if I keep drawing that thing, that path taken by you back, I mean, from the school back home, right? So if I draw it by using dotted lines, something like this, you will go up to there, and then we'll go up to here, and up this point, and then we'll go that way, and then come on, yeah, oh, fine, we'll reach home. But the direction is going to be that way, but it is not a problem because distance is not a vector quantity, distance is a scalar quantity. So along which direction that object keeps moving is not something important when it comes to the distance, right? What matters is the total length of the path taken. It doesn't matter how that path has been taken, whether that path is a straight line or a curved line segment or a combination of a straight line and curved line segment. What is it? Completely immaterial, irrelevant. Okay, so therefore, now let's say in case somebody is going to ask what would be the total distance covered by the object. So come on, journey from home to school, S1 plus S2 plus S3. Now going back, what is it? Again, S3 is being covered, S2 is being covered, and come on, S1 is being covered. Did you get that? So let's say home to school. Distance covered is going to be S1 plus S2 plus S3, right? And from school to home, back journey. In that case, what? I mean, S3 plus, then S2, then come on, S1 will be covered. So you traveled from home to school and then from school to home. So total journey, entire journey is from home through school back home. So total distance which has been covered is equal to, yeah, total distance covered here. And what the total distance covered there, right? So total distance, right? Okay. From home to home, right? Through school to home, starting from home, back home, through school. Okay. So total distance, let's say S is equal to, now when you keep adding, it's going to be 2 times S1, 2 times S2, 2 times S3. So basically 2 times S1 plus S2 plus S3, right? Isn't that so? Now, why I wanted to explain this thing, because now sometimes probably you are capable of solving so, I mean, like very, very challenging problems, but without having proper understanding about tiny salient features, I mean, very, very, very subtle points like this. Now, sometimes some of you think, right? Now I'm going back. So the length of the path taken by me from there to here decreases. When I reach there, it's only up to here. When I reach somewhere there here, it's only up to there. I mean, not all of you, but some of you. Now think, come on. The length of the path from the beginning is getting shorter and shorter and shorter and shorter. See, right? And shorter and even shorter and shorter, and ultimately what? Oh, 0. Which is not correct. Because distance is, come on, always the length of the path taken by the object. So in case you just, I mean, let's say practically you happen to measure the total distance covered by you in your journey, literally what you have to do, come on, yeah, you're gonna lay down a piece of string or rope or wire or thread, right, along the path all the way up to there and all the way up to here. Now you're in the school. Then again, you start, come on, you start laying down additional length of thread, right? Okay, while on your way back, all the way up to here and all the way up to there, and come on, all the way up to here, back home. Now, basically, if you take that the piece of thread, right, out of the path, now actually you are having how many loops? Just you have one loop, but how many pieces are there? There are 2 pieces. One is from, come on, home to the school, and the other one is from school to the home, right? It's just a loop. It comes all the way up to here, and come on, it gets reversed. Okay, again going back up to there, and then again all the way up to here. So once you get a piece of thread, it has gone now all the way up to here and all the way up to there. Two turns are there. So, you know, I mean, like the one turn is exactly, what is it, equal to the other turn. So the total distance, total length is going to be 2 times the length of on one turn. Or just we can say one, come on, the, journey from school to home or from home to school. Now, so if you attempted, let's say, being inside the school, you attempted to move, listen carefully, right? To move in such a way that already covered distance by you should decrease. Did you get it? Now, let's say, now, okay, I saw you in the school, and I'm going to ask Madhudam, can you just, take a few steps in a way that already covered distance is going to decrease? So now you probably will tell me, okay, sir, I'll take few steps, just a few steps of probably maybe towards the Pizza Hut, right? Okay, something like that. Madhudam, I mean, no matter along which direction, no matter along which path, right? Probably you can jump into that, come on, that particular, river, a small river, assuming that that huge crocodile is not there. So in case you do so, even, come on, that distance, I mean, number of steps, right? Taken by you towards the river. And come on, number of steps. Okay, taken by you back to school is getting added to the already covered distance. Right? So Mabutami, okay, right now, probably you're in front of the computer, right? With your device on and probably sitting on the bed, probably on a chair, right? Probably just standing, right? Okay. So if you are, I mean, in a position to move in a way that, I mean, the distance which is covered by you, already covered distance, right, is going to decrease. So let's say you will walk along the wall. So how let's say you are capable of doing so, right? What's going to happen, my dear? I mean, so the path taken by you along the wall is going to have some length. That portion is getting added to the already covered distance. Let's say you took some steps backwards. What's going to happen? Yeah, from where you started and where you are right now, okay, to that point, there are some steps. So some distance is there, some length is there. That length is getting added to already covered distance. Let's say you think, okay, I'll go to the kitchen and I'll meet Ami and I'll have some maybe let's say cup of tea, right? And I'll be back within let's say within about 2-3 minutes. You will be back. No matter how fast, Mabuda, you are moving, come on. Now you have a path to the kitchen and you have another path, probably the same path, probably some different path, right? Back to where you were, let's say your study room. So now again, you have one path to the kitchen, which is going to have some length. And again, you have another length, come on, regarding the second path, which was taken by you from the kitchen to your study room. So now what? My goodness, I mean, first length is from the study room to the kitchen, and the second length is going to be from the kitchen to your study room. These two things are getting added to your distance. So Mabuda, what I'm trying to tell you is this. Now, when you take at least one step, just one step, even let's say a fraction of a step, along any direction, it can be vertically upwards, downwards, sideways, right? I mean, actually, irrelevant. I mean, the direction story is completely irrelevant. If you have taken at least a fraction of a step, fraction of a millimeter, right? Let's say so. Mabuda, it is, come on, some length. So therefore, it is getting added to your distance. Okay, so I mean, the most important story behind this, explanation is this. If you are in school, from home you came to school, let's say now you are there. Manuta, now, if I'm going to ask, please move in a way that already covered distance, S1 plus S2 plus S3, already covered distance decreases. Now let's say Mabuda, put some values maybe, I mean some random values. Let's say this is going to be 10 meters, right? S2 is equal to, let's say 4 meters, S3 is equal to, let's say 2 meters. Let's give some values, right, to make the explanation much clearer. So 10, 14, come on, 16. Now you're inside the school. You have already covered 16 meters. Now, I want you to move in a way that this 16 meters will decrease. Probably you will suggest all of a sudden, right? I mean, I mean, even before the finishing, right? Asking the question, probably you will suggest, sir, I mean, what if I'm going to take, or just I'm going to step backwards, or I'm going to start moving backwards along the same path. What do you think? I mean, probably the most effective case, or probably the most strongest case, you think? I mean, by which you can decrease the length already covered or distance already covered. So even in that case, what's going to happen, right? Let's say you will take 1, 2, 3, 4, 5, 6, 7, 8. Likewise, you take steps backwards. Come on. Okay. You keep covering more and more and more and more and more and more distances. Right? So in order to do so, let's say you came back here. So again, then you come on. Additionally, you have covered 2 meters. Then again, you keep going along that path up to there. You have covered additional 4 meters. Then you will come back home. You have covered additional what? 10 meters. So on your way to school, you have covered 10, 4, 2, already 16 meters. On your way back home, you have covered again, come on, 2, 4, 10, again 16 meters. So what is the total distance which has been covered by you from home back to home via school? 2 times 16, right? So believe me, no object in the universe, no object in the universe can move in such a way that its already covered distance decreases. Never, ever. Correct? No object can move in a way that its already covered distance decreases. Now, for example, let's say the best way, right? The best way. I mean, putting you as an example, you can think, okay, right now you are sitting, let's say on the chair. So just select one fixed point. Let's say the one of the cupboards, right? From that cupboard to where you are sitting right now. Let's say there is a length of 2 meters. Let's say so, right? 2 meters. Now I'm going to ask you to do something. Magutam, please, not too much. Please take few steps in a way that already covered 2 meters will decrease. What do you think? You will move towards the door. Oh, wait. You start taking, come on, an additional path. So length of this additional path is getting added to, come on, 2 meters, which has been already covered. Correct? Probably you think, oh, okay, so wait. I'm going to move towards the cupboard. Now what? Okay. You can do so, but you are going to have an additional path towards, towards the cupboard. So Magda, even in that case, the depending on the number of steps you take towards the cupboard, so the additional distance is getting added to already covered distance. 2 meters. You got it? So where you are right now, I mean, no matter along which direction you will take, at least one step. What do you think? what would be the length of that step? Okay, that length is getting added to that 2 meters, which is already covered from the cupboard. Getting my brother? So my dear, something, I mean, my brother, something which is impossible. One of the big things actually, even though, I mean, things are really simple. One of the big things in physics is that no object can move in a way that its already covered distance decreases. No way. Correct? That's the thing. Right, fine. So I mean, in case you have problems, right, you can ask the let's say there are things to get clarified, or just, I mean, sometimes didn't get the point exactly, right? Exactly to the point I want you to understand, right? So in case you have problems, come on, always you're welcome. You can just disturb. So I have a small question, blah 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 blah, like you can ask, right? So the one of the most, I mean, like the important points I want you to understand before we are going to take the next step, right, is that no objects in the universe, no object in the universe is capable of moving. Very, very important. Is capable of moving in such a way that its already covered distance decreases. No way. So take just one step, I mean, along any possible direction. What's going to happen, my brother? Length of that step, irrespective to the direction, come on, is getting added to the already covered distance. So increasing the distance. My brother, when you look into this graph, right, it is something okay, my dear, fine. So now, okay, starting from 0 with the time, distance, come on, increases, likewise, it increases up to point A, right? And then from point A to B, now you see, now it's distance now. Point A, let's say at point A, that distance is something like 20 meters. Let's say, sorry, 20 meters. Just say 20 meters. Now, in case I'm going to ask, Malputa, what would be the distance somewhere here? Somewhere here? It should be definitely something lesser than 20, right? Let's say that is something like 15 or maybe 14 or maybe like 16, right? What about the point B? It should be even lesser, right? So let's say something like 10. So Malputa, from A to B, object is showing something which cannot be accepted. Come on, in theory, something which cannot be accepted, or something which is not possible is being represented, or is I mean, kind of like the illustrated, right? The from A to B, which cannot be accepted, right? I mean, that was the problem. So in displacement, the object distance could decrease if the direction are different, right? Now, displacement variation. Displacement is something different than distance, right? So we're going to talk about that thing in a while. Just for the time being, I want you to understand what we are talking right now. The concept right now in front of you is the distance. Master that fact. Then the next one. Then the next one. One of the I mean, the important differences, right? You have to understand, and you have to follow when it comes to advanced level. I mean, how advanced level differs from ordinary level, O levels. Basically, come on, with the fact that understanding. So therefore, we are not in a haste, or we are not in a hurry to come on. But going, just jumping, hopping, right? Leaving the stuff behind. But because in advanced level, usually, come on, people are or candidates are not capable or will not be able to succeed in case they do not know exactly what is going behind the screen. That's going to be one of the main differences between advanced level and O levels. Now, O levels or IGCSE, whatever, right? So usually, even without knowing the subject, by somehow by hearting or by somehow, come on, you can make marks. You can score marks, which is not possible when it comes to advanced level. Never, ever. You have to know it for you to get it, this area. Right? Now, it becomes really dangerous when it comes to a subject like physics. Because in case you are planning your career by somehow in something related to science, medicine, engineering, technical, IT, right? Whatever, physics is compulsory. You know what? You can drop chemistry. You can select, instead of chemistry, you can select IT or ICT or something, right? Blah, blah. But physics, what is it? Pivoted. Everything is going around that pivotal point. It's not possible for you to, drop that and continue in the science stream or probably the physical stream, right? Okay. Anyway, just wanted to, show you just the differences, right? You should understand while continuing in advanced level. The way you should look into should be a little different idea than O levels, right? And there should be continuous preparation. Now, O levels usually, within last 3 months, believe me, within last 3 months, usually we can make somebody who is going to go, who is going to score maybe A star or A plus, right? Somewhere around 80 to 90, or even beyond 90. It's possible during last 3 months. Now, when it comes to advanced level, during last 3 months, right, means, it is just, probably the time period during which you are sharpening up the edges, meaning you are going to fine tune your engine, brain, your understanding, right? Not possible to reverse, not possible to make drastic changes, right? Just to sharpen up the edges. By that time, you should be completely equipped so that during that time period, let's say the last 3 months, we can make the edges more and more sharper, right? So that the answers produced by you are going to be, nearly, complete. At least nearly or probably almost complete answers. The quality of the answer is the kind of enhanced. So those things, those improvements can be added during last 3 months when it comes to advanced level. That's all, right? Otherwise, somebody who had, let's say, 50 marks or 30 marks for physics will be made to some 85, 90, 95 just by doing during last 3 months. What do you think? I don't know. If you request even from the God, whether God will accept that request, because probably God might get, I don't know, might get the, what do you think? Angry? What is it? Not angry, let's say. Might say that's not what? That's not, something consistent. You did not prepare yourself during this, during this time period. So you better, go with the flow and see what you can get. Just after the exams, you can start preparing yourself, right, to whatever the result you want. Therefore, so now in advanced level, something very important. You have to have a super confirmed goal. Finally, come on, nicely defined goal. I want this. It is to be established at the beginning of the A-levels. Now you should have done, right? So that, during the rest of the time period, you have to collect all your attempts, your endeavors, right? All steps towards your goal. That's the idea. Right, fine, okay. All fine, good. So that's how it's gonna happen. So then somebody who got up to that point A, right? They had covered 20 meters. Now, by somehow he has taken a few more steps in a way that 20 meters had become 16. My goodness, some steps had been taken. How come maybe 20 meters can become 16? Not 16, right? 16 to 20, it is 4 meters here. So from here to that point, we have 4 meters length path. You got it? Basically, so it's going to be 4 meters distance between that point and this point. It's going to be 4 meters. Now what? Actually, that 4 meters should get added to already covered distance 20. So therefore, total distance should be not 16, but 20 plus 4, 24. So what I'm trying to, emphasize, right? What I'm trying to stress is this point. Up to point A, object is moving in a way that its already covered distance increases. It is okay. It is fine. It can be explained properly. It is completely accepted. No problems. No conflictions. No paradoxes. Right? It's fine. But from that point onwards, graph tells us object is moving in a way that its already covered distance decreases. 20, 19, maybe 18, 17, 16, right? Likewise, that already covered distance decreases towards B. No object in the universe can move in such a way. It's already covered distance decreases. So therefore, what do you say? A to B portion of the graph is trying to illustrate something which is going against physics. It tells us during that portion, object is moving in a way that its distance decreases. 20 becomes 19, 18, 17, 16, 15, 14, right? 12, 11, 10. It decreases. No way. So therefore, come on. As Makuda said, that's why I said it's really appreciated, Makuda, admired, right? And so damn happy. So that portion is completely, completely, what is it? Wrong. Completely, out of the way. Impossible. So that is completely impossible. That is completely impossible. It never happens. Right? So therefore, if you have ever seen, right? Or in case you happen to draw a distance time graph, and that graph by somehow tries to come down, what do you say? Something definitely has gone wrong, right? So a graph like this, it goes that way and it tries to something like that. What do you say? Distance decreases? Never, not possible. And probably maybe it goes that way and it tries, oh, that never happens, not possible, right? Maybe it goes all the way up to there and then again something like that. What do you say? Never. Why? Because during that portion it seems already covered distance decreases, which is not going to happen, right? So therefore wrong. Just say it. Okay, they're right. So therefore, just wanted to make sure that other things are really easy, right? Just wanted to make sure that distance is something you have to understand to the topmost possible level, right? It actually depends on the path taken between 2 points, and it is a quantity which never ever decreases. So if you take at least one step, what is it? Okay, length of that step is getting added to already covered distance. So therefore, it is a quantity which keeps growing, or else it can stay there, right? In case you are not going to move. You got it? Now let's say you came to school, and Mabuda just inside the class, okay, you sat on your chair. Now your sir or your teacher, right? He or she's just teaching, so you keep concentrating without making a move. So just come on. For the time being, distance covered by you remains constant. It is not increasing. There is no way to decrease. So Mabuda, only my 2 things can happen actually. So distance can increase in case you are in motion, or else you moved and now you are at rest. So therefore what? Already covered distance will remain constant. So distance can increase. It can remain, it can remain constant, but never, ever, it is going to decrease. So decrease is something which is not possible with the physical quantity distance, right? That is something I wanted you to understand. To the moon, because everything else is going to be something simple, right? Than the distance. Sometimes probably you have understood other way. In the opposite way. Distance is the easiest. Displacement is difficult. And velocity is even difficult. Actually, come on. Stories? Yeah. Stories negative. Negative means like it's other way around. So distance is the most advanced feature. These are the things inside, right? So therefore, in case, just look into the fact I taught you, and probably now you are completely fine with that, and you got the idea, right? And you are really happy about that. My goodness, of course, yes. Oh, I walked, and then I'm in school, and in case I'm going to take at least 1 or 2 steps towards the canteen, towards the gate, towards the principal's office, right? Oh, length of each and every step is getting added to the already covered distance. Come on, by me. So obviously, yes, distance is something which is about to increase in case we are going to start our motion. That's it. Very fine. Okay. So the whole thing was explained to you, right? In case you have questions, you can ask. Usually, once explained fully, right? Usually, you don't get questions, but yet, come on. In case you have, you can ask, right? No problem. Then the 999 times, it's 1,000 times. Yeah, it's okay, completely fine. You can ask questions so that I'm going to explain. Till you're going to tell me, so I got it. Okay, fine. So in case you're going to recap, let me consolidate. Let me summarize the probably the most strongest concept, right? Throughout the entire section called mechanics. Distance is a scalar quantity, so therefore, there is nothing called along this direction, right? It is just the magnitude, length of the path. So you have a path, you have some length. That's it. And when it comes to two stations, let's say the origin and the destination, right? So let's say 2 points. What is the particular path which was, taken by you or by the object between these 2 points, right? That decides the distance between two points. So therefore, distance is a quantity which depends on the path taken between 2 given points. Right, okay, so it's really clear, right? Between your home and your school. What do you say? If you keep walking, probably you will take a shortcut. And in case you happen to go by bus, so you have to take a particular path. In case you'll be able to go with Tati or Ammi, right? By your car. So probably the path is going to be a different one. But the starting point is going to stay same, your home, and destination is also going to be the school. Same thing, right? But the on foot is one distance. By bus, another distance. By your car, another distance, right? Depending on the path taken. So that's another important aspect of the distance. And probably the most important thing, right? Heart of the distance is, it is a quantity which never ever decreases. Okay, right? Only 2 things are possible. Number 1, it should increase in case that object is in motion. Number 2, in case that object is at rest or object is stationary. What do you think? Okay, that distance covered remains unchanged. Got it? Okay, when that object is going to start its motion, from that point onwards, distance is going to increase. Okay, right. So therefore, a distance time graph like this, it increases, and it is also going to have a portion which represents a decrement of the distance covered. Is not possible. So therefore, this graph is, what do you say? As a whole, this graph is completely wrong and is not accepted and going against the theories in physics. Okay, so Mabuda, how we are going to just establish that nice theory, nice fact of understanding. No object in the universe can move in such a way that its already covered distance decreases. No object, no one. So what about the God? God also, what is it? Same physics. Somewhere they are here, gone, and appeared somewhere they are here. What is it? Some path taken by the God. Okay. So length of the path. That's how in physics. So therefore, what do you say? Yeah. In this tangible world, the physical world, no object can move in such a way that its already covered distance decreases, right? Either already covered distance remains constant if that object is stationary, okay, or else in case object is in continuous motion, what's going to happen now? Distance, come on, increases, further increases, any further increases, and so forth. That's it. Okay, fine, good. Okay, fine. So we're gonna have the screenshot of that, right? And we're gonna make a small note regarding that. Regarding what? Regarding the distance thing. Right, fine. So screenshot is there, and I'm going to upload that screenshot, right, to the group, or probably to the cloud space. Right, things will be back on track, right? As I promised you, during the last few sessions, right? Fine, okay. So we talked about we had the topic and about the distance, right? Yeah. So fine. We can make a note. So in your notebook, NOTE note. NOTE note. Right. Another thing. That graph. Okay, that graph should be there. Probably you have already taken down, right? Assuming you have taken down the graph already, right? So I'm going to dictate a few things, right? You can take down by the side or below the graph, right? So let's say according to the graph given above, according to the graph given above, the distance covered by the object, increases, right? One more time from the beginning. According to the graph given above, the distance covered by the object or distance covered by the object increases up to the point capital A, and from capital A to capital B, it seems distance decreases. This is not possible. Fine, full stop. So from the mid of the next rule, different colors. So we can say no object in the universe can move in such a way that its already covered distance decreases. Now that's something really, really important. So right. no object in the universe can move in such a way that its already covered distance decreases. Never. Right, fine. So, having taken down the thing, right, from the mid of the next rule, back to normal colors. Therefore, AB portion of the graph. Therefore, AB portion of the graph AB portion of the graph cannot be accepted as distance decreases, cannot be accepted as distance decreases, and therefore graph is erroneous. ERRORNEOUS. Graph is erroneous. Graph is erroneous. The meaning graph cannot be accepted. Why? Because there is huge error. There is a huge error. So it tells us something is moving in a way that its distance decreases, which cannot happen in physics. Okay, done. So that's that. Right. And now, next day onwards, right? Now, you have idea that fact sheet number 1. So I want you to have a highlighter so that I'm going to ask you to highlight important points so that you can have the regarding the particular day. So yeah, important points, and sometimes spaces are left, right, for you to solve problems, for us to discuss problems, right, and so forth. Okay. So most probably, you are not going to write notes, right? Instead, you will have this, all these resources with you. Now, fine. Okay, that's about the distance, right? So what we took down, let's say number 1. Let's note number 1, and from the next rule, note number 2. So what are the possible things? Now we talked about the distance, and we said distance never decreases. So it can either increase that way, right, or else should remain constant, right? It can go up to there, can remain constant. So object is stationary, object is not moving any further. So now what? Distance remains constant. Or else, object is in motion, distance increases. Yes. So continuously. Right. Note number 2. Note number 2. Let's say there are two possible things. With the distance. There are two possible things with the distance. Now the fine, full stop. Distance should continuously increase. Distance should continuously increase, or should remain constant. Right. Okay, fine, good. Now Right, fine. So that's all about the distance concept, right? And Mabuta may we talked about something called gradient, right? So can you remember? Now, if I ask, what do you mean by the gradient? I mean, can you remember the way we defined the gradient? Now, in advanced level, right? Not in O-level version, not the O-level version, advanced level version. I mean, most accepted accurate version. What is the definition of the gradient? How do you define gradient? Come on. How do you define gradient? What is the gradient of a graph? Gradient of a graph is this. What?
So the variance of y, the variance of y per unit x.
Maguda, can you remember the definition? I mean, formal definition. We talked about. It's just the regarding the delta y over delta x, right? That's good. I mean, like it's okay, but right, fine. Maguda, no, while doing O levels, right? Probably even from below grades. So we got this idea. Gradient is just either delta y over delta x, right? Y2 minus y1 over x2 minus x1, or probably increase in y per unit x, right? Or change in y per unit change of x, something like that. I mean, all these things are little okay. I mean, in one way or another. Maguda, but I mean, none of these falls, right? None of these falls. I mean, falls into the systematic definition of the gradient. Now, gradient is to be defined properly, right? Before we are going to just, get our hands with the next few concepts, right? Which includes the problem solving as well. Maguda, we can just in years delta y g rho the tangent, then use delta y delta x. Yeah. That's usually that's how usually we say, right? So if we take let's say y-axis, and x-axis, y, x, and Maguda, let's say we have a straight line and which intersects that x-axis at that point. So when it comes to the right hand side with respect to that point, with respect to this point, right hand side, all x values are greater, right? Now, for example, let's say if it is number 2 here, all values lying on that side are going to be greater than number 2, right? 2.5, 3, 4, 10, 100, and so forth, right? So all numbers are going to be greater than that coordinate of x. and all the coordinates lying behind, right? Number 1, 0, -1, -2, -10, blah, 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 right? Come on. Towards the negative infinity, all numbers lying behind or towards left. What do you say? Are going to be lesser than, smaller than that value of x. Can I make you find something on you, right? Okay. So therefore, as these values are greater, if when you take that particular position, if you take this level, right? So this side is called, as these numbers are greater than that number. This side is called positive x direction. Positive x direction. Right? And following the same phenomena. This side is called negative x direction. Right. But now, why that side is called positive x direction is because now, for example, if the value here is number 2, number 1, and number 3, number 4, number 5, right? You take any one of these values towards right side and subtract value here, definitely you will get many common, some positive answer. Now, for example, let's say you will take 5 and you subtract that number. So it's going to be plus 3. That's why we say positive x direction towards that side. Right? Then it's clear why we say negative x direction. Because if you take okay, -1, -2, right? Take, for example, let's say -2. You will take -2 minus, see, minus the value here, number 2. Oh, you take -1, right? -1 minus 2. Answer is going to be -3. Negative x direction. Right? So therefore, when you take a straight line, where that straight line is supposed to intersect or cut the x-axis marker, with respect to that point, right side is called positive x direction and left side is called negative x direction. Right? And now with that positive x direction, can you see straight line makes an angle anti-clockwise. Let me erase this part, right? Number 3, I just write here. So this angle, wow. See the sense of the arrowhead? Anti-clockwise. It is not along the same direction as that of the, come on, as that of the indicators of the clock, right? Hours hand, minutes hand, seconds hand, they keep going this way. Clockwise. What is this? Anti-clockwise or counterclockwise. Two words are available. Anti-clockwise or counterclockwise. Anti-clockwise, ACW. Counterclockwise, CCW. Clockwise, CW. Right. So this is what? Anti-clockwise or counterclockwise. Okay. So then once you get the straight line and once you locate the point of intersection with respect to that point, get the positive x direction and locate the angle made by the straight line. Come on. Anti-clockwise or the anti-clockwise angle. Now, once you get the tan value of that angle, gradient simple m is defined, very important, defined as tan theta. Got it? right? So that is the definition of the gradient. Sir, delta y over delta x, probably it is numerically, magnitude wise, right? Size wise is equal to that gradient. So y2 minus y1 over x2 minus x1, probably that's also, come on, magnitude wise is equal to that. So change in y per unit change in x, that is also size wise, come on, the equals to the gradient. But none of them is the definition. Did you get them, Abhudha? So in case, I mean, let's say you're I mean, much towards the maths, or probably the you're continuing in math stream, right? So in case they will ask for the definition of the gradient, it should be exactly what I taught you, right? So one more time, I'll go through. Now, Mapuda, first of all, you have to figure it out. So just, I mean, inside your mind's eye, draw the y-axis, draw the x-axis, get that straight line, locate the point of intersection, get the positive x direction, select the anti-clockwise angle, and get the tan of that angle. Nothing but the tan value of the angle is defined as the gradient of the straight line. Get it, fine. So now listen carefully. I'm going to dictate one more time, right? You can literally take down, right? I mean, but listen carefully. Gradient of a straight line is defined as the tan value of the angle which is made by the straight line with the positive x direction in an anti-clockwise sense. In an anti-clockwise sense. Right? Okay. So that's the definition of the what's called this gradient. Now, if you take the, let's say, small triangle somewhere here. Now, what is that? Probably that is delta y, right? Some change in y. And whatever this portion, that is some change in, come on, x, delta x. Now, if you take this theta angle and angle here, they are equal to each other. Why? Because these two line segments are parallel and intersected by another transverse line. So these two angles are, what do you say? Corresponding angles. Corresponding angles. So tan theta here should be equal to tan theta there also, right? Because theta remains constant. So tan theta is now what? Opposite over adjacent. Got it? So therefore, I mean, if I mathematically, progress through, tan theta is delta y over delta x, right? So, which can be explained as the ratio between, come on, change in y, change in y to the change in x, or else we can say increase in y or change in y per unit change in x. Either one of these explanations will be okay, but remember, those are explanations, not the definition. Everybody fine? Okay, now the fine. So let's start. Note number 3. Note number 3. It is the def dot of gradient. Definition of the gradient. Ready? Okay. Def dot of, short form. definition of, short form, def dot of. Gradient, simple M. Ready? Okay. Different colors to your hand. Different colors from the mid of the next row. Nothing. Different colors means what? Yeah, red color is the best, right? So from the mid of the next row, gradient of a straight line, gradient of a straight line, gradient of a straight line is defined straight line is defined as the tan value we can write as the tangent of the angle made by the straight line with the positive x direction in an anti-clockwise sense. In an anti-clockwise sense. Gradient of a straight line is defined as the tangent of the angle made by the straight line with the positive x direction in an anti-clockwise sense. Anti-clockwise sense. Very fine. Now you should be able to understand. I mean, it's actually self-explanatory, right? Why we should emphasize that anti-clockwise sense? Because with respect to the positive x direction, somebody can go other way around also. Somebody can go this way also, which is going to be clockwise, right? So it's not that angle, it is the anti-clockwise angle. Right. So that's it. Fine. So now I'm going to erase that, right? The screenshot is there, right? So I'm going to upload the screenshot. All these screens. Well, now something really important, and at the same time something which is which seems to be little hard, right? Only seems to be little hard, or probably intentionally made little harder by you, right? So therefore just listen carefully and try to understand. The next concept is going to be something which is really important and lying at the heart of problem solving, as well as something which prevails throughout the entire syllabus. Probably during the last lesson also, right? I'm going to talk about that gradient, this one, that gradient. So can you see it is connected to this one this way and so forth, right? Okay, right, fine. So now if you take a graph, let's say y, and here we have the x. So let's say generally we have one straight line like this, right? And okay, positive x direction, anti-clockwise angle, right? So gradient is tan theta. Gradient simple m is given by tan theta. Now we know that, right? Now, when you take the tan value, let's say so few angles 0 and let's say 30 and 45 degrees, right? And let's say 60 degrees and let's say 90 degrees, right? Okay. So just to explain, for the sake of your understanding, right? Right, I'm going to write tan, and here we have the angle, right? The side angle. So now, if I write a value here, what is that? Tan 0 value, tan 30, tan 45, tan 60, tan 90, and so forth. Tan 0 is 0, tan 30 is 1 over root 3, tan 45 is 1, tan 60 is root 3, tan 90 is something called infinity. Now, these values can be obtained. These values can be obtained by using general geometry, right? I mean, almost all these values. I'll just show you one simple thing, right? I mean, so that you can understand. Okay. It is not something from the heaven. Geometrically, simply we can obtain these ratios, these values. So how did you write those values? I mean, did God communicate with you? Probably, I don't know. Mabuta, anyway, but the thing is, I mean, what I know, I mean, to the best of my understanding is that what? I mean, all these things can be obtained in case you have the understanding, right? Okay, fine. So let's stick to on these angles. Let's say 30 degrees, right? Now, 30 degrees, what I'll do is I'll take one, let's say a right angled triangle. So that this is going to be 90, and let that angle to be what? 30 degrees. If it is 30, that is 60, 90. So what about that? It's going to be 60, right? So this one is going to be 60. Right. Now, Mabuda, so if you have something like this, so you can write tan 30 opposite over adjacent. Okay. So therefore, what we have to do, just I mean, in order to obtain the tan 30, so in case you will be able to locate a right angled triangle whose one angle is 30 degrees, then what? You are done. Just get a 30 degrees angle, go to the opposite side, get the adjacent, then opposite value over adjacent value. What is it? Is the tan 30? Right? Simply, that's the idea. Mabuda, therefore, what I'm going to do, me having this idea in my mind, I'm trying to just, I mean, establish something like this. See, will you? This is an equilateral triangle. So what did you say? Equilateral triangle. All sides are equal. So therefore, what is it? So each angle is going to be 60 degrees. Simple geometry. I mean, your the probably come on. Not all of us. Let's say grade 2 probably. Yeah. Equilateral, isosceles, right angled, right? All this, right? Anyway. Now, all these sides are going to be 60, 60, and 60. So let the most important thing, let the length of sides to be whatever you want. But the thing is, can I say let the length of the side to be 2 centimeters? What is it? No. Mabuda, why? Because 2 centimeters is a specific value, particular value. Now, this triangle is a, come on, the sides, lengths of the sides should be general. Should be able to take any value. Any value. Not only 2 centimeters, 10 centimeters, okay. 100 centimeters, okay, no problem. 11.5 centimeters, yes, no problem. 78.35 centimeters, yes, okay, you can take it. So it should be that general, right? That's the idea. Length we can't assign because length has to be general. Okay, they're right. So what I'm going to do, I'm going to say let the length to be simple A. Simple A. So simple A can become, come on, if you want 2 centimeters, if you want 100 centimeters, if you want any, whatever you want. That's it, fine. So I'm going to say that's going to be simple A. So it is an isosceles triangle, right? I mean the equilateral triangle. So what? Sides are equal. That's also going to be simple A. This one is also going to be simple A, right? And now, my Buddha, I want to think about that 30 degrees thing. So what I'm going to do, I'm going to drop a normal, right? So which is going to bisect that third side perpendicularly. While, come on now, okay, bisecting that angle as well. This O level probably, come on, grade 5-6 geometry. So this angle, which was 60, is getting divided into 2. 30. Did you get that? So I have found a way to get a right-angled triangle. Not only one, at least, I mean, come on, 2. Right? Whose one angle is going to be 30, the other angle is going to be 60, therefore. Right? We are so cunning now. So that's going to be 30. This angle is also going to be 30. Geometry, right? This is going to be 60. And that's going to be 90. This is also going to be 60. What about that side? Half A. A over 2. What about this side? Half A. A over 2. Okay, there, right. Now, if you take this, one of these right-angled triangles, see, right? Let's say I'm going to take that right-angled triangle, Mabuda. The one which is hashed, right? Now what? It's a right-angled triangle. So this side is equal to hypotenuse squared minus this squared square root, right? You got it? So length of that side is equal to what? A squared minus A over 2 whole thing squared square root. Did you get that? Pythagorean theorem. I applied Pythagorean theorem, right? This side squared plus this side squared should be equal to this side squared. So square of this side minus square of that side, okay, get the square root is equal to this side. Okay, then fine. Now, what is that? Let's say this is equal to A squared minus A squared over 4 square root. 3A squared over 4. 3 times A squared over 4 square root, which is equal to root 3 simple A over square root 4 is 2, right? Got it? Got it, sir? Yes. Right. There might go now. Oh, we got that side. Oh, all right. What is that? 3 times, root 3 times A over 2. So I can just write, okay, this side should be equal to root 3A over 2. Now, take one of these right-angled triangles, right? So if I go for this this right-angled triangle, which is hashed, tan 30. Tan 30 is equal to opposite. What is opposite side? A over 2. A over 2 divided by adjacent. Adjacent. What is adjacent? The one we found, root 3 over A over 2. root 3a over 2. Now what? Denominator getting cancelled. A getting cancelled. 1 over root 3. Wow. 1030. Got it? Let's know. So therefore, 1030 is equal to 1 over, root 3. So therefore, I mean, it was from the heaven or from the hell. What do you say? No, it's just the understanding, right? Simple geometry, my dear. And in case, I mean, you tried to remember these things, you thought, oh, it is just given by the calculator. I don't know. Without the calculator, I have no maths, right? What is it? Right. Okay. It's not that it's something programmed. No, it is having only limited capabilities. This calculator, no matter how powerful it is, right? So we have developed this thing which is unlimited. Okay, right, good. Now, what I'm going to, do something additional, right, for the sake of your understanding. That's regarding 30 degrees now. So you can go for now, come on, even for 60 degrees. Just to check whether it is going to be root 3, right? Tan 60, you can write it. 60 is equal to tan 60, opposite, come on, root 3a over 2, now divided by 460 adjacent, a over 2, a divided by 2. See what's going to happen? 2 guys are getting cancelled, a guys are getting cancelled, just leaving root 3. Whoa. Tan 60 is equal to root 3. Isn't that so? Okay, there, right. So now I showed you something regarding geometry as well, right? But that's not my aim. I mean, it was done to enhance, to expand your brain capacity. But because once it is done, once you are a little above the scope of the syllabus, what is it? I mean, you're going to be grade 10, right? And leaving your paper in grade 7. So that's the theory behind what? I mean, successful rankers. Those who are going to score more than 90 or probably even 100. Remember, should always, learn little about 2 centimeters beyond the scope of the syllabus. Make sure about that thing, right? I mean, if you make sure about that thing is going to confirm your A, what? Yeah, A plus. Cambridge A stars, right? Okay, fine. See my dear. Tan 0, 30, 1 over root 3, which is some decimal. 45, 1. 60, root 3, which is 1.732. Something greater than 1. And 90, infinity. Infinity means something huge. Infinity is greater, right, than the biggest number you can ever imagine. Did you get that? Now I'm going to ask Manputam. Think about the biggest possible number for you. Just think about the biggest number which you can recall into your brain. Just think about the biggest possible number. Infinity is something which is even greater than that. That's how we just introduce the concept called infinity. Remember, infinity is not a number, it is just a concept. So what about infinity divided by infinity? Infinity divided by infinity. Oh, same, least equal 1. Oh, what is it? We could have do so, right? I mean, it is possible in case these were numbers. Carrying some values. They are not carrying some values. Infinity is a concept. Now, when I say concept, it is something like this. What if I write like this? Mother divided by mother, or equal, so is equal to 1. What do you think? It's a big question, right? I mean, it's not going to work. That's wrong. Mabuta, likewise, this is also wrong because infinity is not a number, it's a concept. Mother is not a number, it has no numerical value. It is a concept. Mother, ma, ammi is a concept. Right? So mathematical operations cannot be conducted. Correct? So that's the idea. Right? Okay. So these things are not correct, right? Okay. Just I wanted you to, understand anyway. Infinity is something really big. So now what's going to happen along that way? Angle increases, right? Isn't that so? See, Mabuta? Along that way, angle increases. So I can just write angle increases. Right? What is happening to the tan value? 0, 0 point something, 1, 1.732, something, 1,000 million, billion, trillion, even greater. So tan value is also going to increase. Wow. Tan value increases. Okay, that's all what I wanted to talk. I mean, come on, implant in your mind. But did all these stuff, why? Wanted to expand your mind, brain capacity, right? Because it is required to become, top in the country, to become top in the world, right? So in my list, in Cambridge, there were 3 of your seniors who became top in the country. And there were, 2 out of those 3, right? Mabuta became my first class engineers. So that's how. So you also can. It's not a dream anymore. It is something to be achieved, right? Only question is whether you have decided to pluck. Whether you have decided to get it. So yes, I have decided. Fine, that's all. Then let's go. Let's say it. Fine, okay, good. So therefore, what's some of the lesson I need here? What's the lesson here? Angle increases, so tan value also increases. Wow. What is tan value? What is tan value? What is tan value? Tan value, gradient. Tan value is gradient. So come on. Angle increases, tan value increases. So what do you mean by tan value increases? Gradient increases. So ultimately, angle increases. Therefore, gradient increases. Right? Okay. So gradient increases. That is what I wanted you to know about the comment. Yeah. Just where? So it's going to be that way, this way, and it is that. Ultimately. Good. So tan value and angle value are directly proportional. No, never. I'll just ask one small thing. Question, right? Yeah. Now something is increasing, and depending on that, Another thing is also increasing. Just that increases, this increases. Oh, we can't say they are directly proportional. In case for them, okay, to be in direct proportionality, when you double one, the other side should also get doubled. When you quadruple, meaning 4 times bigger, the other side should also become, quadruple. 10 times greater, 10 times. Oh, one side is halved, H-A-L-V-E-D, halved. The other side is also getting halved. That variation is there. Then we say, come on, yeah, one is directly proportional to the other. Now, shall I ask one more question from you, right? Angle here is 30. Angle here is 60. Now, 30, 60. Angle is doubled. Ooh, what about the tan value? This is 2 times this. No. 45. 90. 90 is 2 times, 45. Doubled. What about these two values? 2 times 1 infinity. Never. So, even though you doubled the angle, tan value does not follow that. So, what do you think? Angle and tan value, they are directly proportional or they are not directly proportional. What is the name? Come on. Come on. That's it. You can ask questions. You can understand. You can answer. Not directly proportional. Really good. You got it. Mabuda, you know what? Now you can teach that to your friends, sometimes even to your teachers. In case one of your teachers, right, including me, right, will tell you, theta and tan theta, they increase, no? Theta increases, so therefore tan theta also increases. Oh, they are directly proportional. You have to go against. I mean, no need to make, big, right, problems. I don't agree with that. It is not so. Just increasing is not directly proportional or direct proportionality. It demands one side is doubled, the other side is also getting, doubled. This side n times, that side is also by n times. This side is halved, that side is also halved. That side 1/3, this side is also getting 1/3. Same factor is being followed. Then fine. It is called, direct proportionality, which is not being followed here by the angle and the tan value. So therefore, even though when you increase angle, tan theta also increases, they are not following the same, same pattern. It's not when theta gets doubled, tan theta gets doubled. It's not when tan theta is halved, theta is getting halved. So therefore, they are not directly proportional. Fine, okay, even though they increase. Okay, fine, good. Okay, my dear, welcome. Right, good. So therefore, it's done. Basically, this is, generally, this is what I want you to understand, right? Definitely to make you are one of the exceptional and identified personalities in physics, right? In school or anywhere you go, right? You're gonna just leave your signature there as one of the masters in physics, right? I'm gonna make sure, right? So make sure you got this area, right? You have ample opportunities, chances to keep asking questions in case you have problems, right? Okay, so basically, angle increases. Oh, tan values also increases. That's it. Direct proportionality, no. But they just increase. So tan value, on the other hand, come on, was defined as the gradient. So what do you mean by tan value increases? Gradient increases. So let's take that side. Okay, angle increases. So let's get what we want from the other side. What is it? Gradient increases. Angle decreases. Gradient decreases. Right. Going in order, angle decreases, tan theta decreases, therefore gradient decreases. Done. Okay, good. Now the fine. So everything is there, right? Everything is there in the screenshot. So once that thing is uploaded, so you can develop your note in case you won't. In case you feel I couldn't take down that point, blah blah blah, right? So you can develop your note on your own. Once that screenshot is uploaded, right? Anyway, we should take down this small portion. After this thing, right? So the big story, different colors to hand, my brother. Different colors to hand, right? From the mid of the next row. Now we are under note number 203, right? So number 302. So let's say, therefore, it is obvious that. Therefore, it is obvious that when theta increases, when theta increases, tan theta also increases. Tan theta also increases. And therefore, gradient increases. Gradient increases. Gradient increases. Okay there, right, fine. That's it. I'm going to erase, right? No worries. Nothing to struggle. So in case you have I wanted to take down that part. I wanted to I couldn't take down this one. I couldn't see that thing properly. Just come on. You can rely on the screenshot SS, right? In case you want the recording, ask for that. Fine. One of your big friends, Magda, you have to be careful, my dear, and these days, right? At the same time, take care about your health as well. Just think about yourself, because going on trips and everything can be done after exams. But in case you will get sick, or not feeling well, so you have to stop everything, right? Which is going to be a problem when it comes to exams. Why? Because this is the time during which you should do your maximum, right? In case you have decided to reach your goal. I ask you one thing, Malgudami. Now let's say top in country. Okay, it is there. It's not a dream. It is actually all about. It's all about whether you have decided to touch it, get it, make it yours, or you have no idea about that, or you are not, confident enough. So I'm going to get it. So Mabuda, it is about that decision. How firm that decision is, how strongly you nourished, you made it. That's it. Then now what you have to do, just till the end of the exams, keep collecting all your attempts, your endeavors, right? All these your steps towards that goal. That's it. Fine. Okay, good. Next one is going to be something like this, right? Now see how it is getting connected to this theory. Now I'm going to draw a graph. So you know what? You're going to be masters of the graph theory, right? Just you look into the graphs and you will make all decisions. Just believe me. So here I say we have X, we have Y, and we have a straight line, right? Magadam, I want you to I want you to pay attention fully, 100%, or if possible, even greater than that. And hold yourself here, right? And come on, interact with me. Just we have a little distance, right? But what? Assuming that you are just in front of me, whisper, murmur, chant, or just come on, yeah. Biologically, come on, yeah. Be with me together, right? So that even you can't prevent subject flowing into your bloodstream. Correct? Okay, fine. Manputam, it's a straight line. So, what about the angle made by this straight line with the positive x direction? Did you get the question? It's a straight line. So, what about the angles made by that straight line with the x direction? We have the answers here. You are that fast. Accurate. And obviously accurate. Right, good. But I know, Magadam, most of you are having the answer. So, accurate. That's true. At the same time, constant. Isn't that so? Magadam, why, my dear? Because, that angle is theta. Well, you can make a copy of the x-axis and place it here. Okay, this angle is also theta. I'm not going to explain why, because I don't want to. Yeah, I don't want you to feel kind of like shamed. Why? This is, my goodness, grade 2 corresponding angles. So somewhere down here, copy of x-axis, again theta. Somewhere down here, copy of x-axis. What do you say? Again theta. Magadam. Tan value here, theta. Tan value there, theta. Tan value here, theta. Tan value there, tan theta. Theta remains constant. Come on. Tan theta remains constant. Now, inside your mind's eye, what is tan theta? Gradient. Now, come on. So, therefore, gradient remains constant. Did you get that? One more time with me. Come on. Theta remains constant. So therefore, tan theta remains constant. Oh, inside your mind's eye, tan theta is nothing but gradient. So what? Gradient remains constant. Understood? Good. Therefore, I'm going to say theta remains constant. Therefore, tan theta remains constant. Therefore, gradient remains constant. Did you get that? If you by-hearted, you were given with so many graphs and you were just forced to remember line is like this, constant gradient. Line is like that, no gradient. Line is like this, negative gradient. My Buddha, if it is the way you were holding these facts in your mind, you didn't learn properly. Definitely you didn't learn. Right? Instead, let me tell you, you by-hearted something which is not going to work anymore. Right? Never. Now, humbly being one of these first-class engineers, I'm telling you, right? I mean, it will never, ever going to work in any further. It's all about the understanding. Right? So one more time. Come on. Theta remains constant, obvious. Therefore, tan theta remains constant. Yes. What is tan theta? Oh, gradient. A gradient remains constant. Correct? Okay, fine. Let's see another one. Here we have y-axis. Here we have x-axis. And there's a straight line given that way. Abhidham, can you tell me about the angle made by this straight line with the positive x direction? Oh, why keep typing? My goodness, stop will you? Wow. 0, 0, 0, 0, 0. Really happy. Really good. And I'm waiting, actually anxiously waiting to meet you. Abhidham, why? Because we have to perform so much. I mean, like, it's just, I mean, not your exam. It seems like, it's my exam. Let's do this, right? I mean, like, let's see. And let's show, right? Silently, right? But powerfully and inconvincible, unstoppable, right? Let's show how capable you all are by voice. No, never. By, come on, performances. That's the idea. Okay, fine. Mapata good. So angle is going to be 0, obviously. Angle remains 0. Theta. And even there is no angle. Here we have the, in case you will draw copy of x-axis. Take a copy of x-axis and paste it here. It is going to be on top of that line segment. No angle is made, just 0. Right? Theta is equal to 0. So I'm going to say theta is equal to 0. Magda, can you remember that tan value I gave you in the previous table? Sir, can't remember. Don't worry. No worries at all. You have this bugger. Come on. Take that one on. Then right hand side. 1, 2, 3, 4. From the top, 4th button, you have tan. Tan. Then press 0. Then equal. You will get this right. Got it? Mabudam, which tells you, which shows you tan 0 is equal to, come on, 0. Let's say, for example, Mabudam wanted to, take tan 45. Tan 45. 1. Right? Tan, let's say, 60. See. Root 3. Can see, right? Yeah. So you have this for anything, right? But while we are teaching national, I think I have mentioned about that thing, right, already. While we are teaching national syllabus, which is about like 10 times deeper than Edexcel as well as Cambridge. So they do all, let me tell you the word, block capital ALL, all simplifications completely manually. Right? Okay. Fine. So then what? Tan theta is equal 0. So therefore, what about tan theta? Tan theta is also equal to 0. What? But tan theta is what? Gradient. So therefore, what? Gradient is equal to, what do you say? 0. So Magadam, what about that graph's gradient? 0. What about that graph's gradient? That gradient is, what is it? Oh, constant gradient. Can you remember we talked about quadrants? Can you remember? Quadrants, first quadrant, second quadrant, third quadrant, fourth quadrant, all St. Thomas College, all ratios positive. Only sine positive, only tan positive, only cos positive. All St. Thomas College. Oh, can you remember? Something like I can remember something like that. Oh, no, sir, no, sir. You didn't teach something like that. What is it? Can you remember? Right, fine. So if I say, Malpuna, this angle, the as one of you, I think Pudashian, right, told me. So acute angle, Malpuna, yeah, acute. For example, let's say 60 degrees, that theta seems to be 60 or 45, something like that, right? Anyway, acute, less than 90 now, less than 90. So angles fall into first quadrant. So trigonometric ratios, sine, cos, tan. Not only those three, right? I mean, there are a few more, but for the time being, that's more than enough, right? Sine, cos, tan ratios of all the angles in the first quadrant are positive. For example, let's say this angle is 60, sine 60, positive value, cos 60, positive value, tan 60, positive value. Right? So, I mean, you got that? Okay, fine. Then we have gone through that concept. Cyclic quadrants. Malpuna, in case I did not teach you that part, come on, it's your responsibility to let me know. Sir, we didn't do something called cyclic quadrants. It is very, very important. Right? Malpuna, it is not my dear me, something with your, I mean, with your skills is always there. You are always competent and you have skills and so capable. You know what? It is the pedagogy. So what did you say? Did you say something? Yeah, pedagogy. Pedagogy means teaching order. Right? When someone doesn't know the way to teach, the flow of teaching, Malpuna, you feel so damn bad about that subject. You start hating that rather than falling in love. Why? Because what is here is not getting matched with the other one. And what is given there is not getting matched with this one. So you feel, come on, yeah, blocks are coming from the heaven. And those blocks are also so heavy. But you start hating. So if you take 100 students, right, who are doing physics, out of 100 students who are doing physics, Malpuna, believe me, more than 90 will definitely say that is the hardest subject. Which should be other way around. Which should be other way around. Right? The subject, I mean, for which you should work, come on, least the subject for which you should have maximum understanding. Subject for which you can score maximum. Believe me, easily. But I mean, given one thing, you understand. Understanding, that's very important. Understanding makes you perform. Practice makes you perfect. Somebody had said something like that, but it's very, 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 come on, practical. Let's say that. Good, okay. Malpuna, so therefore, this theta value is acute now. So less than 90. So therefore what? It falls into the first quadrant. So tan values are positive. So if you want, you could have said the gradient simple M is greater than 0, which means positive. Here it is equal to 0. Okay, the another one thing. My Rehan at the beginning just said, sir, that gradient, how come it's going to be negative and so forth, something like that. Okay. So let's say we have a graph like this. So now I'm going to mark these angles, that angle theta, and this angle as alpha. Now I want you to answer this question, Magda. I want you to answer. In case I want to get the gradient of this straight line, should I stick to theta or I should address alpha? What do you say? I should go for alpha or I have to go for theta in case I want to get the gradient of that straight line. That goes with your understanding. Right. I think Prashin wanted to tell me, yeah, theta, ne? Yeah.
So theta.
Theta, Mabuda. Good mind. Right. Okay. That's it. Nice. Super. Mabuda. I'm so happy. You know what? Because once that is given properly, the way to get the angle which goes with the gradient, once that thing is properly given to you, you know how to do it. So you know what? In case physics or chemistry or maths or biology or something else is, or seems to be difficult, or you feel so difficult, or you feel so scared about that subject, Mabuda, probably you are learning that subject from the wrong person. This is not told by me. Actually, I quoted that. It was told by one of the Nobel Prize winners, right? Professor Richard Feynman. If you feel the subject is difficult or seems to be difficult, probably you are learning the subject with the wrong person. Can you find? Okay, done. Okay, so it's going to be theta, obvious. Why? Because get the point of intersection, get the positive x direction, anti-clockwise angle. My goodness, it should be theta, right? Okay, so not you. Probably you will get your small brother, your small sister. She or he is going to answer that question properly. I'm pretty sure about that. Okay, good. Then that's going to be gradient. So that theta. But that theta is, greater than 90. Now, when it comes to that cyclic quadrants, all are same. Only sign is positive regarding angles in the second quadrant, which are obtuse angles. So therefore, tan value, cos value, should be negative. Right? Now, this angle, theta, again remains constant. See? Okay, this angle is also theta. Take another copy somewhere here. Okay, this angle is also theta. Obvious, why? Corresponding angles. Now, by the definition of the gradient, simple M is equal to tan theta. Pretty sure about that. But you know me, sum of these two angles is equal to 180 degrees because straight line angles, right? So you have alpha plus theta is equal to 180 degrees. So therefore, theta is equal to 180 minus alpha. Simple thing, right? Now what can I do? I can replace that theta by that block. Take that theta away, get the block and put it there, right? And therefore, simple M is equal to tan 180 minus alpha. Simple thing. Now, there's a small thing I just wanted to mention. This thing can be written Just believe me for the time being, right? In case you are doing maths, you will learn about that thing in detail. Probably you have already, or else you will learn definitely. But those who are doing maths, completely fine. Those who are doing biology or just some bio, right? In the bio stream, just believe me, because we don't want, oh, just something they are not going to ask you to prove this. Instead, the result is the most important thing. In case you know, this is how it is going to be, or this is the way to look into that thing in a different angle, that's more than enough, right? Okay, so this thing can be written as minus tan alpha. Now, this mathematically we can prove, right? Tan 180 minus alpha is equal to minus tan alpha. What I want you to remember is only this block, nothing else. Because in physics, they will never ever gonna ask how to get that. No, never. In case you know it is there, or this is equivalent to that, more than enough. I mean, things are going to work like wizard. Right now, see, alpha, as this angle is obtuse, definitely alpha is some acute angle. For example, let's say theta is equal to 120. Then this is going to be 60. So therefore, this is tan 60, but with the minus sign. Tan 60 is root 3, and with the minus sign, minus root 3. Right? So therefore, now this gradient is, come on, minus some positive value. Alpha is acute, alpha is smaller than 90. So therefore, alpha is acute. So tan alpha is positive. But as because we have a minus sign in front of that, come on, entire thing becomes negative. Probably that is why Mahaputa Rehan at the very beginning regarding that gradient, that distance time graph, told me, so how comes the AB portion negative gradient? Why that negative gradient is? Oh my goodness. I am not too sure whether that negativity with that AB portion of the graph, Mahaputa got it with the full understanding or by-hearted. Graph like this, negative gradients. Graphs like that, positive gradients. Shia. Never should do like that. That is not, come on, part of the rankers. That might be fine. So always we go for how it is and therefore. Reason and, come on, effect. Effect, reason, cause and effect. That's all. So that's called know it all. Okay. Now fine. So therefore, now this angle theta is obtuse. Okay. So therefore, alpha is acute. So acute angles means less than 90. So therefore, all these alpha values are going to be in the first quadrant. So therefore, tan values are positive. But with that minus sign, entire thing is going to be negative. So therefore, I can say it is a negative, well, negative, constant, see, gradient. Wrote everything with the full understanding, right? I mean, like negative, you can explain. Constant, you can explain. Gradient, you can explain. Why? Because you just took tan theta into account. Tan theta is the definition of the gradient. So you are right now we are talking about the gradient. Okay, done. So just come on, 2 more graphs. No worries about this, right? In case you couldn't take down, I mean, like, nothing to worry because everything is available. Okay. Now, see, my dear, how you are going to analyze another two graphs? I mean, to keep the doors open for the next day session, right? Okay. Right. Now, I'm going to take a y-axis, x, y. It goes that way. I want you to analyze the variation of the gradient of that graph. Right. What about theta? What about theta while going that way? Theta. See, tangent somewhere there here. Tangent somewhere there. Tangent somewhere there here. What do you think? I'm so happy theta increases. I didn't say anything. You told me. Absolutely. My Buddha, theta increases. Now it's something, come on. Is it magical or logical? That's it. Okay, fine. So theta increases, right? So I'm going to say theta increases. Therefore, I don't have any doubt regarding tan theta. Tan theta increases. Ooh, tan theta means gradient. So therefore, gradient simple m increases. Simple m increases. Margotha, can you see all these theta values are acute? So therefore, tan theta positive. So gradient, what is it? Increases, but gradient is positive. So let's write some improved version, right? Negative. Positive gradient increases. That's it. Next one. See how the things are becoming your second nature, right? So a graph like this. Nothing to just come on, explain. Theta at the beginning is going to be something like that. Theta somewhere there is going to be like this. Theta somewhere there is going to be like that. Theta somewhere there is going to be like this. Ooh, what's happening? Theta decreases. Come on. Theta decreases. Tan theta decreases. Gradient decreases. All these theta values are acute. So therefore tan theta positive. So gradient is positive always, but decreases. So how we write? Positive gradient decreases. Can you find? Okay. So theta decreases. Therefore, tan theta decreases. Therefore, gradient decreases, but it is greater than 0. See my dear, right? Theta decreases, tan theta decreases, therefore gradient decreases, but gradient is fine, greater than 0. Here we have x, here we have y, and let's say we have a straight line, right? It's a straight line. And right. Analyze the gradient. First portion is a curve like that. Then after that is a straight line. theta decreases. And then after that, theta remains constant. Come on. Tan theta decreases. Tan theta remains constant. Gradient decreases. Gradient remains constant. Positive gradient decreases. Positive gradient, come on, remains constant. Can you imagine? Yes, sir. Okay. So this portion, theta decreases, tan theta decreases. So gradient decreases, but gradient is greater than 0. That one, theta is equal to constant. So therefore, tan theta is equal to constant. So therefore, gradient simple M is constant. And simple M is greater than 0. Right? Okay. Fine. So this is what I want you to do. I mean, homework, highly worthy. Right? Highly worthy. Number 1. It goes all the way and then come on, stays straight. Explain, right? Number 2. Number 3. Zero. Okay, fine. So the number 1 is a portion, and then after that straight line. Number 2, straight line, and horizontal line segment, and curve. It's a curve and a straight portion, and then after that, come on, yeah, curve. So what you have to do, just number 1, number 2, and number 3, just write how that gradient is going to vary, right? Like this, right? So gradient angle story, therefore tan story, therefore gradient story, and depending on the value of the theta, whether that theta is an acute angle or an obtuse angle, right? So just write the nature of the gradient, whether it is a positive gradient or a negative gradient, right? Okay. So fine. That's all about that, and we are going to meet on next day. And tell me anything you want to get clarified.